sharing my screen. And as I do that, I got an email from somebody who hasn't been attending class all that regularly, asking me because the schedule said that test one was supposed to be today. And I responded that we were going to do one last type of problem today that we hadn't looked at, then we were going to review, and that test one would be available over the weekend. And so what I've got is I'd like the homework done before you take the test. So right now this assignment is due on Saturday. If that is problematic for anybody, I can push it back till Sunday or Monday. But I do want the test done by the end of the day, Sunday. And I have to apologize now that I'm looking at it. Let me just make sure when it is available. It will be available after 11 o'clock today. The test is in my math lab. You're going to put your work in Blackboard. The problem set is also due by, and I apologize, I think I said that was Monday, that's Sunday. So both of these are due on Sunday. Again, the problem set counts as a quiz, but you don't have to submit your work, and you can retake it as often as possible, and it's the best practice for the test. That having been said, does anybody have questions about any of those? You guys are so quiet. Is everybody okay with this?
Yeah.
Okay.
Yes.
Then before we get looking at that last topic and going over that review, I am wondering if anybody wants to look at anything homework-wise from this chapter. Remember, this chapter started with things as basic as your properties, order of operations to simplify things. Then we looked at the laws of exponents and scientific notation. Then we looked at simplifying radicals, rationalizing denominators, and negative and fractional exponents. Then we looked at polynomials, add, subtract, multiply, and divide. Then we looked at factoring, and now we're looking at a key use of factoring, which is that working with algebraic fractions. Does anybody want to look at any homework questions from the rational expressions, the factoring, or for that matter, anything previously? Or did anybody start doing that problem set and have a question on any of the problem set problems? Have I waited long enough? Any questions, folks? Is anybody scrambling to find something, or are we all good?
I think I'm all good.
Okay, then next place we're going, last new topic that I think will be at most one question on the test, deals with complex fractions. We're going to say that a complex fraction is a fraction that contains a fraction in its numerator or denominator, or both. Contains a fraction in the numerator, denominator, or both. And we want to simplify it. We want to be able to express it without a fraction within the fraction. So if I, you know what? All of a sudden I'm doubting myself. Just want to make sure. Does it show that we're recording from your end, guys?
Yeah, it does.
All right, all of a sudden I had a weird feeling that maybe I had forgotten. Thank you. So let's look at an example. Let's look at x over 3 minus 1 over x minus 3. And you notice there's a fraction inside the fraction. And I don't know about you, sometimes it almost like blows my mind. I can see why they call it complex. It's pretty complicated. The process was a couple of different ways of simplifying a complex fraction. One would be to do all the work in the numerator, then all the work in the denominator, and then treat the fraction as a division problem. But there's a much shorter way of clearing that fraction within the fraction, and so that's what we're going to look at. In order to do that, what we're going to do is we're going to find the least common denominator of all the fractions within the fraction. And so I'm going to rewrite that fraction x over 3 minus 1 over x minus 3. As I look at that fraction, does everybody see the numerator has 2 terms, the denominator has 2 terms, and between those 4 terms, the least common denominator would be, well, the only denominator I see there is 3. Everybody all right so far? Then, what we're going to do is we're going to multiply both the numerator and denominator of the complex fraction by that least common denominator. You have to distribute. Give me a second, please. You have to distribute if necessary. And sometimes, after I distribute, I like to write it as the least common denominator over 1. So, what the heck does that mean? Well, we've got this x over 3 minus 1 over x minus 3. Do you guys need me to wait a minute because of writing? I kind of have a tendency to forge ahead. Does anybody want me to hold off for a second, or are we all ready?
If you don't mind, that'd be good.
Okay, speak up if you need me to do that. I get on a roll because this stuff is so much fun. And you guys don't have to roll your eyes at me when I say that.
Okay, I'm good. Thank you.
So we said we want to multiply numerator and denominator by that least common denominator, 3 over 3. Again, I think I said this when we were looking at adding and subtracting fractions and getting that common denominator. Please notice that what we're multiplying by, 3 over 3, is just the number 1. And so we're not changing what it equals. We're only changing what it looks like. And when I multiply both numerator and denominator by 3, because both the numerator and denominator have multiple terms, I have to distribute. So distributing, I'm going to put that as 3 times x over 3 minus 3 times 1 over 3 times x minus 3 times 3. So is everybody okay seeing the distribution there? Not hearing any complaints? When I said sometimes I like to put that common denominator over 1, is everybody familiar from arithmetic with that idea that if I multiply a fraction by a whole number, usually it's easier to see if I put that whole number over 1. And so then, right now it looks worse than it did, but if I chose that right common denominator, when I do this multiplication, notice that those denominators would divide out, cancel out. So I'd be left with x minus 3 over 3x minus 9. And now, last thing we need to do is simplify if possible. And again, remember, if you're going to simplify a fraction, we have to divide out common factors. So usually, before you try to simplify, you want to see if you can factor anything. And so looking at that denominator, does it jump up and bite anybody else on the nose that there's a common factor of 3? So my numerator is prime. I'm not going to factor that. My denominator, when I take out that common factor of 3, oh, now there is a common factor between the numerator and denominator. And so my final answer is just 1/3. And if I compare 1/3 to up at the top with the fraction already, originally looked like, do you see why they call it simplify? Doesn't it look a lot simpler than it did when it began? I know when I teach the calculus class, I like to say, make sure if you can, you simplify things first, because it's called simplifying because it makes your life simpler. So, but in any which case, how does that problem look? Shall we try a few more? Is everybody
Yes,
done?
definitely, please.
Next example then. I'm going to have 6 plus 1 over x over 5 minus 1 over x. And again, as I look at this, I see the numerator is made up of 2 terms. The denominator is made up of 2 terms. And between those 4 terms, between 6, 1 over x, 5, and 1 over x, what would you say the common denominator is? Is anybody else noticing that the only denominator that I see is x? So that will be my common denominator. That decision okay for everybody?
Yeah, it's okay.
And so now I'm going to take that fraction and multiply both the numerator and the denominator by x. Again, I'm multiplying numerator and denominator by the same thing. I'm multiplying by x over x. So I'm only multiplying by 1. In the numerator, I have to distribute, and I get 6 times x plus 1 over x times x. In the denominator, I have to distribute. I get 5 times x minus 1 over x times x, where I'm multiplying that fraction by a non-fraction entity. I'm going to think of that plain old x as being x over 1. So in the numerator, 6 times x is 6x. In the denominator, I can think of simplifying that product, and I just get 1. In the denominator, 5 times x is 5 over x. And then when I multiply 1 over x times x over 1, again, I can think of those x's dividing out, simplifying that product. And so I've got 6x plus 1 over 6x minus 1. Is that reducible? And as I look at that, I think not, because 6x plus 1 is prime, 5x minus 1 is prime. Neither of them factor, so they have no common factors. Ready for another one, folks?
Yep.
Next example. Let's look at 1 over x squared plus 2 over x minus 3 all over 1 over x squared plus 1. Now that we've got it written down, The numerator is made up of 3 terms. The denominator is made up of 2 terms. Between all of those terms, what would you use as a common denominator? Any ideas?
X.
I like X as a start.
X the second.
Beautiful. When we're looking for that common denominator, we're looking, if there's a common factor, we want to use that highest exponent. Beautiful. So now I'm going to take that numerator and multiply it by X. And I'm going to take that denominator and multiply it by X. And again, because I'm multiplying the top and bottom by the same thing, I'm only multiplying by 1. So I'm not changing the value. Oops, and it wasn't X, it was X squared. Sorry, folks. And so now doing that multiplication, I have to distribute. Gives me X squared times 1 over X squared plus X squared times 2 over X minus 3 times X squared. And in the denominator, I get X squared times 1 over X squared plus 1 times X squared. And just for a hot second, that looks much worse than it started. But if you choose the right common denominator, notice here the X squareds cancel, and I'm left with 1. Notice here, X can go into X squared, X times, so I'd be left with 2X minus 3X squared. And in the denominator, the X squareds would cancel. I'd be left with 1 plus X squared. Now, if you wanted to see if it simplifies, I want to look at that. I have to decide whether I can factor first. I'm going to look at that denominator. And that denominator is a binomial. I've got perfect squares, but it's addition. So that denominator is prime. And since the denominator is prime, I'm not going to worry about trying to simplify it because it does not factor. So that this would be my final answer. So let's try one more. This one's the make you think question. Look at this one. Y to the negative first minus y plus 5 to the negative first over 5. Is there anybody else looking at that one and your first gut instinct is, wait a minute, that's just a fraction. It's not a complex fraction. Or at least it doesn't look it. But what we have to remember is a negative exponent means I'm taking the reciprocal. And I can't just move that in the bottom because there's this subtraction in between. We can only move things from numerator to denominator to change the sign on that exponent if it's all multiplication. So that y to the negative first is actually 1 over y. And that binomial to the negative first is actually 1 over that binomial. And then my denominator is just 5. And I can think of that as 5 over 1. We need a least common denominator. So again, I see 3 terms here. If I were trying to add those 3 terms, from the first fraction, I need a factor of y for my common denominator. From the second, I need a factor of y plus 5. And from the third, I guess technically I need a factor of 1, but we don't need to show multiplying by 1. So now I'm going to take that original fraction, and you don't necessarily have to rewrite this as many times as I am. I'm rewriting it so that people who aren't here, when they look at the notes, it kind of makes a little bit more sense. We're going to multiply the numerator by that common denominator, and we're going to multiply the denominator by that common denominator. Again, because we've got the same in the numerator and denominator, we're just multiplying by them. Distributing, I'd have that common denominator times 1 over y minus that common denominator times 1 over y plus 5 over 5 times that common denominator. And again, for a hot second, it looks messy, messier than it did before. But if I put this over 1, if you notice here, the y's would cancel out, divide out as I multiply. So that just becomes y plus 5. Here, if I put this over 1, you see how the y plus 5s would match up, and I'm left with just minus y. And in the denominator, just for a second, I'm going to leave that factor. Now when I simplify, y minus y, that just leaves me with 5 over the 5y times y plus 5. And does everybody see that 5 is a common factor? So I'm left with 1 over y times y plus 5. And doesn't that look a lot more simple? When we simplify it, doesn't that look a lot better than what we started with? Any questions? And so what it took us like 20 minutes to go through that. We were 20 minutes behind where I had hoped we would be at this point in time in the semester when I set up the schedule over winter break. And so what I had hoped we would just be doing today is going through a practice test to kind of get everybody in the mindset to take that test over the weekend. Before I open up, I took the liberty of uploading a digital copy of the practice test to the notes today to work on, because I've noticed when I just write on top of my lab stuff, my penmanship gets horrific. The stylus and writing on the website and Zoom aren't always good friends. Before we get started looking at a review, does anybody have any questions on what we just did?
Nope.
No. Does it look kind of logical? Not too bad? Okay.
Yeah.
So I left 2 pages in between in case anybody had wanted to go over anything from the homework, but not hearing any. I'm going to go over and hit on this thing that's called print questions, and I'm going to make it a lot bigger, and hopefully you'll remember that the chapter got a little bit more involved as we went through it. Please notice as we go over these problems, what I'm going to show you is the minimum amount of work that I'd like to see. Because again, if you show me work, I can give you partial credit. If all I have is a wrong answer, I can't. So question number 1 asks you to evaluate the expression for the given values of the variables. Help! What should I do?
Plug in your X and Y.
So x is 7. So x squared is 7 squared minus 5 times x is 7 minus y is 2. Then what do I have to remember to simplify?
Order of operation.
Order of operation can start in the parentheses. So that's 7 squared minus 5 times, let's see, 7 minus 5. Hello, it was 7 minus 2. Guys, yell at me when I make a typo. Minus 7 minus 2 is 5. Then exponents, 7 squared is 49. Then multiplication, 5 times 5 is 25. 49 minus 25 is 24. At the beginning of the semester, for some folks, I think work like that seemed a little involved. Does it seem easier now that we've added so much to our knowledge? Next question is similar. It says the formula C equals 5 nines F minus 32 expresses the relationship between Fahrenheit temperature F and Celsius temperature C. Use the formula to convert 23 degrees Fahrenheit to its equivalent temperature on a Celsius scale. So 23 Fahrenheit means we're going to substitute in 23 for F. And so that gives us C equals 5 nines. F is 23 minus 32. 23 minus 32, I believe, is negative 9. When I do that multiplication, I get negative 5. That one all right. Then you have to recognize your properties. So let's see, as I look at 8 plus parentheses 9 plus 3 equals parentheses 8 plus 9 plus 3. I guess we could approach this through a process of elimination. It's all addition. So I think we're going to knock out these properties of multiplication. Now, let's see. The associative property of addition says, let's see, how things associate, how things group together. It just changes grouping. Does everybody see here? I am same things being added. I'm just changing the grouping. So that's my associative property. It's not the commutative property, because for the commutative property, we change order. And we're not, the order in which they're written did not change. It's not the identity property of addition, because that would be adding 0. And it's not the inverse property of addition, because that would be adding a negative. So know your properties. Four asks us to simplify the given algebraic expression. The expression is 9 times parentheses 7y minus 7 close minus 2y plus 2. Order of operations says to start inside the parentheses, but they're not like terms. I can't do that. So now what should I do?
Distribute.
Beautiful. And over here, in the first one, I'm going to distribute the 9. And then does everybody remember in the second one, I'm going to distribute, because it's subtraction, negative 1. So 9 times 7y is 63y minus 9 times 7 is 63. Minus 1 times 2y is minus 2y. And this is where you got to be careful that negative has to get distributed to the other terms in that parentheses also. So that's going to give me minus 2. And now like terms, 63y minus 2y is 61y. Minus 63 minus 2 would be minus 65. That one okay?
Yes.
Asks us to remember some of our rules for exponents. Does everybody remember when you raise a power to a power, what do you do with those exponents?
I believe you multiply them.
Beautiful, you did correctly. So that'll give me x to the negative 16. And then it says to write it with a positive exponent. Should I just change that sign? I don't think so. I have to remember that negative exponent means 1 over x to the positive power. And so when I change that sign, I need to remember to take the reciprocal. Next one again asks us to simplify using our exponents. Answers can only have positive exponents in it. This looks like it's a fraction, so it's a division problem. So I'm going to take that negative 15 and divide it by 3. And then I'm going to pair up the common bases. X to the 13th divided by x to the 4th. Y to the 5th divided by y to the 3rd. Dividing negative 15 by 3 is negative 5. Now over here with the common basis, if I divide, what should I do?
Subtract.
Subtract the exponents. Beautiful, big base stays the same. So that's x to the 13 minus 4 is 9. Y to the 5 minus 3 is 2. While the coefficient is negative, that's okay. The exponents are all positive, so I'm done. That one all right. Is this pacing okay? Am I going too slow for you guys? Am I going too fast for you guys? Are we all right?
This is pretty on pace. Yeah.
Now we've got a number in scientific notation. We want to write it without exponents. So I've got negative 7.03 times 10 to the 6. That's a positive 6. Since it's a positive 6, I want to move the decimal in the point that would increase the magnitude, make it bigger. So I'm going to move it 6 places. 1, 2, 3, 4, 5, 6. Gives me 703, and I need to add 4 zeros. It was a negative number, it stays negative. And I'm going to put in commas. I don't think they want you to type commas in my labs. I think they want you to just write the number. Does everybody remember their scientific notation? Question 8 asks me to use the product rule to simplify the following expression. Assume that variables represent non-negative real numbers. The reason that's in there is because if my variables are non-negative, I don't have to worry about whether I need to throw in absolute value signs or not. The product rule says I'm going to just multiply the radicands because they're both the same index, they're both square roots. So 8 times 32 is 256, x to the 3rd. And now let's see, 256, is that a perfect square? Anybody want to try taking that square root of 256 and telling me if it comes out evenly?
Got 16.
Oh, beautiful. That's 16 squared. X cubed is x squared times x. Remember, if we have an odd exponent, we want to factor one out. And so that gives me 16x times the square root of x. Rationalize the denominator. Does everybody remember that's a fancy way of saying you don't want to leave a square root in the denominator of a fraction? So usually we just multiply by the radical that's in there. except, damn it, when there's two things. And does everybody remember when there's two terms involving a radical in the denominator? Can anybody remember what we had to multiply by?
Conjugate of the denominator.
The conjugate of the denominator has those same terms, but the opposite operation. In the numerator, I have to distribute 8 radical 5 minus 8 radical 2. And then in the denominator, because they're conjugates, does everybody remember? Even when we were looking at polynomials, when I take that product of the sum and difference, it's the first one squared minus the second one squared. And when I square radical, I just lift the square root symbol. So that just becomes radical 5 squared is 5 minus radical 2 squared is 2. And so I get 8 radical 5 minus 8 radical 2 over 3. Over here, where it says type an exact answer using radicals as needed, they're kind of saying, don't you dare just pull out your calculator and turn that into a decimal. If you turn it into a decimal, it's no longer exact because this is an irrational number. You would be rounding. They don't want you to round. They want you to leave it exact in radical form. That one all right. Does everybody remember that process? That's usually something that sometimes by the time we get to the end of this chapter, people have forgotten. Remember it. You'll see that over the weekend. Perform the indicated operation. Does everybody remember if it's subtraction? The first thing I want to do is distribute my -1. So there'll be 7x to the third minus 10x squared plus 7x minus 7. First polynomial stays the same. Distributing the -1 changes the signs on the second one. So it becomes negative 10x to the third. Negative times negative is positive 10x squared. Negative times negative is positive 7x. Negative times positive is negative 8x. On this quiz, in life in general, careless mistakes occur when people forget that they have to multiply everything in there by that -1. You change all of those signs, not just some of them. Now, like terms, 7x to the third minus 10x to the third would be negative 3x to the third minus 10x squared plus 10x squared, 0x squareds. I don't need any more x squareds. Plus 7x plus 7x is 4 plus 14x. Minus 7 minus 8 is minus 15. When it asks for the degree of the polynomial, if it's a polynomial in one variable, the degree is just the highest exponent on the variable. And so the degree is 3. That one okay? Next one asks you to find a product, and we're squaring a binomial. I am going to always, when I have a binomial squared, take the time to write out that that means I'm multiplying that thing by itself, and then seeing it written like that reminds me that I have to FOIL or distribute twice or box. And so when I combine like terms, I've got 4x squared plus 12x plus 9. The other way of doing this is to use that pattern where it's the first term squared. The product of these would be 6x, doubling that gives me 12x. And then the last one squared. But 9 times out of 10, when people do it without foiling, they have a tendency to forget that I do need that middle term. Question 12, the MyLab's direction said to use the FOIL method. I don't care if you use the FOIL method or the distribution of the box. Use whatever method you use to multiply. And so, not gonna lie, I am a FOILer from way back. But boxing or distributing twice, you'd get the terms 6x squared plus 5xy minus 24xy minus 20y squared. And then simplifying, combining those like terms, gives me 6x squared minus 19xy minus 20y squared. Wow. Next one asks us to follow the trinomial or say it's prime. Again, a couple of people have asked me to say that it's prime means that you've tried everything and you cannot factor it. But we haven't tried anything yet. Let's try to factor this thing. It's got a leading coefficient of 6. Well, it starts and ends in 6. 6 isn't a common factor because 6 doesn't go into 13. So I can't common factor it out. I'm going to ask you folks, would you be more likely to do this trial and error? Or would you be more likely to do this using that AC method?
I think trial and error. I haven't used the AC method since we learned it, so.
Trial and error, where I have that 6x squared minus 13x plus 6. 6 can be 1x times 6x, or 2x times 3x. 6 can be 1 times 6, or 2 times 3. And I'm looking at the 1s and 6s and thinking that if I did it so that the 1s, the 6s got, no, actually I digress. I'm looking at the 2s and 3s. If I do it so that the 3s get multiplied, that would give me 9. And the 2s get multiplied, that would give me 4. And 9 and 4 would give me that 13 in the middle. So let's try the 2x and the 3x. Signs are the same, both minus. And I said that to get the 4, I wanted to put the 2 where it would be multiplied by the 2. To get the 9, I'd put the 3 where it would be multiplied to get the 3. Also, because there is no common factor, I don't want to really put the same number in both parentheses. And now if the I'm thinking this is the right answer, but let's check. First, 6x squared, outer minus 4x, inner minus 9x, last plus 6. Yep, that gives me that negative 13x in the middle. And so my answer will be 2x minus 3 times 3x minus 2. And because I could factor it, I'm not going to even think about the possibility of checking that it's prime. That one all right? Can I scooch up? Oh, I love this one. It says factor the difference of two squares. Well, the difference of two squares, that was that a squared minus b squared equals a plus b times a minus b. So where I have q to the 4th minus 1, well, q to the 4th, that would be q squared times q squared. 1 would be 1 times 1. 1's a plus, 1's a minus. But look at down here. Do you see how it says factor completely? Does everybody notice we're not done yet? Because I still have the difference of 2 squares. So final answer, the one with the plus sign does not factor, but the one with the minus sign can be q plus 1 times q minus 1. And so that's my final answer. Gonna give you a heads up. A silly, common, careless mistake that I see when I correct things like this is some people just intrinsically don't like using different letters for their variable. And so without fail, a question like this, I have a person typing in X's instead of Q's. And I can sort of understand where you're coming from. You can't change the variable. So if it's Q, leave it as Q. Is that one all right? Next one, well, this is what we've been looking at. It's dividing fractions. Does everybody remember, in order to divide, we're going to leave the first one the same. Change the division to multiplication and take the reciprocal of the second one. And then we said the rule to multiply is really just factor. X squared minus 4 factors into x plus 2, x minus 2. 8x minus 8, there's a common factor of 8, leaving me with x minus 1. X squared plus x minus 2, that gives me, let's see. Oh, what happened there? 2 and 1. Signs are different. I think if this is a minus and this is a plus, that'll give you the positive in the middle. And then the last one, x squared plus 4x plus 4. For x squared, if I use x and x. For the 4, if I use 2 and 2. Signs are the same, both pluses. That'll give me the positive 4 in the middle. Now I'm going to match, see what's the same. The x plus 2's are in common, numerator to denominator. The x plus 2's are in common, numerator to denominator. The x minus 1's are in common. So what I'm left with is x minus 2 over a. That's my answer. But do I need to exclude anything? When you think about that idea, exclude, somebody in my Monday, Wednesday, Friday class stayed after to say, what the heck's that all about? That means that I can't have a 0 in the denominator. And so I have to look at all of my denominators. This denominator can't equal 0. So if I worry about where that equals 0, I will get x is 1. So x cannot equal 1. This denominator can't equal 0. Well, that factored into x plus 2, x minus 1 equaling 0. And so I can't be 1. I said that already. And I can't be negative 2. But also, after I flip it, this denominator can't equal 0. And so that would be x plus 2 times x plus 2 equaling 0, which is also that negative 2. And so I guess those are the only two values that I can't have. And so if it's asking you about what to exclude, remember we're setting those denominators equal to 0. And I'm not going to lie, I usually do this at the end because I find it easier to do once I've got all of those things factored, to think of just setting each factor equal to 0. How's that one? Is everybody okay with this last part? What do I need to exclude? Hearing no questions. Next one's an addition. And remember, in order to add fractions, I can't just add those because they have different denominators. Because I've got just a little bit amount of real estate available to me on this page. I hope you don't mind. I'm going to try to condense some of what I have written out several times before. Common denominator, neither denominator factors. So my common denominator is going to be x minus 5 times x plus 7. When I look at this denominator, it's missing the factor of x plus 7. So I'm going to multiply that numerator and denominator by x plus 7. Distributing the numerators gives me 3x plus 21. And the denominator is x plus 7 times x minus 5. Next one, in order to get the common denominator, it's missing the x minus 5. And again, I have to do the same thing, numerator and denominator. So that gives me 2x minus 10 over that common denominator. X plus 7, x minus 5. Adding the numerators, then I get 5x plus 11 over my common denominator. Because that numerator does not factor, it's not going to be reducible. Again, they ask me what must be excluded. I have to remember that the denominator can't equal 0. So if x minus 5 equals 0, I get 5. So x cannot equal 5. And if x plus 7 equals 0, I get x equals negative 7. So x can also not equal negative 7. So this would be my answer, and I have those values to exclude. Evaluate the expression without a calculator. Does everybody remember that if my exponent is a fraction, I'm going to draw a radical? Rewrite the expression using the radical. That's what I'm looking for. The denominator is in the index, so I want the fifth root of 243, and I'm going to square it. Back in ancient times, recognizing the fifth root of 243 is 3. Squared is 9. In terms of without using a calculator, what you need to be able to do is write it as a radical first. And then in terms of getting the simplified answer, I guess I won't have a hissy fit if you use a calculator to find it. 17, all right. Are you guys still there?
Yeah.
Is all of this coming back?
Slowly but surely.
It's been a little bit of a while, so we've covered a lot. And please realize this is chapter P. This is the preliminary chapter. When Mr. Blitzer wrote this textbook, this was stuff that he was hoping people had in their bag of tools before they started the course. We want to make sure everybody's on this equal playing field. Here, factor the polynomial using the formula for the difference of cubes. Well, that formula is a cubed minus b cubed, because it's a difference. We're going to have a minus b, keep the same. Square the first. This is minus, opposite sign. Multiply the 2, and then add the square of the second. So where I have z cubed minus 343, I think everybody can recognize the cube root of z cubed is z. So this will be z squared, this will be something times z, and some number squared. Now what we have to do is we have to figure out what's the cube root of 340. I apologize, I misread it, 343. So what number to the third power gives me 343? What number times itself 3 times is 343? If you're not sure, you can use your calculator to get it. You'd be able to find the cube root function on your calculator, or remember, cube root would be raising it to the 1/3 power. Does anybody get the cube root of 343 is 7? I take 7 times 7 times 7. It's 49 times 7, which would be 333. So here I'm putting in a 7, here I'm putting in a 7, and here I'm putting in a 7 squared. So that this would be your answer. I'm concerned. Is everybody got a way in which they're comfortable if it's telling me that I've got cubes to find a cube root of 343? Does anybody need help finding that? Not hearing anything, I'll just go on then. Simplify the rational expression. Find all the numbers that must be excluded. Okay. Simplify a rational expression just tells me I've got a factor. So the numerator, common factor of 2, x minus 5. Denominator, let's see, x squared is x times x. 25, signs are the same, both minus. I think if we do 5 times 5, when I multiply it out, I get that 10 in the middle. I can divide out that common factor. So reduced form is 2 over x minus 5. And then numbers to be excluded. I'm worried about what makes the denominator equal to 0. Again, I find it easier to solve that if I take the factor form. And if I worry about what makes each factor equal to 0, I would get that 5. So x cannot equal 5. 19, all right. Exponential notation. If you wanted to, you could simplify what's inside the parentheses. 14 divided by 7 is 2. X to the 13th divided by x to the 2nd is x to the 11th. Y to the 2nd, 7th divided by y to the 2nd is y to the 5th. Now we're raising it all to the 0 power. And does everybody remember, if I raise anything to the 0 power, it's equal to 1. So I guess this one, if you recognize that that was a 0 power, you didn't even need that middle step. You could just go straight to the fact that it's 1. Simplify the exponential expression, and we want to write it without negative exponents. If I have a product to the power, I need to take each factor and raise it to the power. And again, I can do this because notice it's all multiplication in there. If there were addition and subtraction, I would not be able to. A number to a negative power is 1 over that number to the power, positive power. When I raise a power to a power, I'll multiply exponents. Negative times negative is positive. Multiply exponents. Positive times negative is negative. Multiply exponents. Negative times negative is positive. Then 4 to the 3rd is 16 times 4 is 64. If it has a positive exponent, it remains positive in the numerator. If it has a negative exponent, that factor hits a positive exponent in the denominator. And if it has a positive exponent, it remains positive in the numerator. And so I am thinking we have choice. Next one, we're multiplying a binomial by a trinomial. Remember, it's repeated distribution. I'm going to take x times the x squared plus 6x minus 7 and negative 12 times the x squared plus 6x minus 7, giving me x cubed plus 6x squared minus 7x minus 12x squared minus 72x plus 84. So I have x cubed, 6x squared minus 12x squared would give me minus 6x squared. Negative 7 minus 72 is negative 79x plus 64. And so it looks like that's choice 2. That one okay?
Yeah, that one's okay.
Next one asks you to factor. And again, whenever I factor, the first thing I look for is something in common. And it jumps up and bites me on the nose. Those are all even numbers. So I'm going to take out a 2. Taking out a 2 leaves me with 3x squared minus 4x minus 4. And now I'm going to try to factor that. Please notice, because I could take out a 2, I know it's not prime. Now to factor what remains, let's see. 3x squared can only be 1x times 3x. 4 can be 1 times 4, or 2 times 2. And that was my common factor. That's got to stick around for the while. You can have x and 3x. I'm thinking if I use the 2 and 2, I could have different signs. I could have 2x and 6x, which would subtract to 4. To get the 6, I'm going to put the 2 here. To get the 2x, I'm going to put here. For the negative 4, I'm going to have this one negative and this one positive. And again, we'd have to check my formula. 3x squared plus 2x minus 6x minus 4 gives me what I want. And so let's see, which is that? That's choice B. That one okay? If so, next is a multiplication. And again, in order to multiply, in order to simplify, what I've got to do is factor. Over here, I have the sum of 2 cubes. So I'm going to take the sum of the roots. First one squared minus the product plus the last one squared. Down here, does everybody notice those are all divisible by x? It's a common factor, leaving me with x squared minus x plus 1. And hopefully everybody's smiling because they notice those two match. 10x, LE, and now here, those two both have a common factor of negative 90, leaving me with x plus 1. X plus 1 is a common factor. X is a common factor. So that leaves me with 10 over negative 90, or negative 1. That was fun. I think they're fun when everything cancels out. It doesn't always happen, but when it does, it makes it worth the factor. Is everybody comfortable with that one? Simplify the complex rational expression. All right, this is what we were just looking at. And so what we've got to do is we've got to find the least common denominator between, let's see, my denominators are x minus 6, and the other one is x squared minus 36. Well, that one factors into x minus 6 times x plus 6. And so the common denominator would be that product. So I'm going to multiply both the numerator and the denominator by that product. The numerator, when I distribute, I'll get x over x minus 6 times x minus 6 times x plus 6 plus 1 times x minus 6, x plus 6. In the denominator, I have 27 over x plus 6, x minus 6 times x minus 6, x plus 6 plus 1 times that product. And it's a pain in the ass to do all that writing, but that idea of finding the common denominator and then distributing it to both the numerator and the denominator, I'm done. Here, in the numerator, the x minus 6's cancel. So I'm left with x times x plus 6. So that's x squared plus 6x. And here, that would be x squared minus 36. So that numerator is 2x squared plus 6x minus 36. That denominator, the entire x plus 6x minus 6 cancels. So that gives me 27 plus that's x squared minus 36. And so in the denominator, I have x squared minus 9. It's not an option, so I think we've got to simplify that. To simplify that, in that numerator, there's a common factor of 2. X squared plus 3x minus 18. And that would factor into 2 times x plus 6, x minus 3. The denominator factors into x plus 3, x minus 3. So now I can simplify by dividing out the x minus 3. And so it looks like we did distribute the numerator. 2x plus 12 over x plus 3. Choice D. How's that one? And that's the end. You're going to find that the test has 25 questions, very much like these. The preliminary test, the practice test, has 16. So make sure you take that practice test several times. And in your studying, you might also want to revisit this document. Any questions on any of those questions? I know the complex fractions relatively new. We just looked at that today. If you have questions during complex fraction homework, I'm just the Ask My Instructor button away. I also can meet with you. I have a Zoom office hour right after class today, and I have a Zoom office hour on Friday morning. Does this document look doable to you folks? Do you remember it all? Are you guys going to all do well on this test? Is anybody? Go ahead.
with complex fractions, when you're distributing like in 25, how it's x minus 6, x plus 6.
Mhm.
So it would be x over x minus 6, and then you'd have a separate fraction of x minus 6 times x plus 6 over 1, and
Uh-huh.
that's how you would distribute it. You wouldn't distribute those into like x. You wouldn't do like, no, I'm trying to. All right, yeah, I get it now. Yeah, yeah.
You're not doing the repeated distribution because there's no addition in between those two birds? So you're
Okay.
just treating that as a single thing that you're multiplying both by.
Okay, so that's like it's one full. It's not two separate like equations.
Right.
Okay, thank you.
Anything else? Now, I have to tell you guys, I had thought that this would take us all the way till the end of class today, and we've got a half an hour left. I don't necessarily have anything planned to do during that half an hour. If you want to, we could pull up another copy of the problem set and go through it together. If you want, I can revisit anything that you might have question-wise on any of the homework. If you want, I can shut up and stay in Zoom and have you folks work on things on your own, and if you have questions, ask. If you want, we could start looking at the next chapter, or if you want, we can call it a day. I'll leave it in your hands. What would you folks prefer?
I wouldn't be opposed to more practice problems. I would prefer to get a good grade on this test.
Okay, so you want to go through another problem set together?
I would be okay with that if
I wouldn't mind.
anyone.
Yeah, I can second that. And especially probably those last two problems on there, if we could do something similar to those.
Sure. All right, well, let me go into sharing my screen again. Let me go into my labs. Let's look at preview. Oh. It's denying me access because I was out of there for a while. Let's look at the problem set again. All right. Shall we go through the whole thing, or shall we scooch, go backwards, assuming that the latter ones are the end of the chapter and more involved? Oh, this is fun. I don't think we looked at something like this last time. Let me try to make that bigger. Here we're subtracting two fractions. And as I look at them, does everybody see that we've already got that common denominator? And so I'm going to keep the common denominator, x squared plus 8x plus 7. And I'm going to subtract the numerators. And remember, I like to write it like that, so we remember to distribute that -1. So that numerator would become x squared plus 5x minus x squared plus 5. So that numerator becomes, I apologize, I'm running out of space here. 5x plus 5 over x squared plus 8x plus 7. Does everybody notice that numerator factors, common factor of 5, leaving me with x plus 1? Because they're asking me what to exclude, I want to think about factoring that denominator. And sometimes, especially if I'm going to be reducing fractions, I'd like to see the factors that I have and see if that might help me. And I think it is, because to get x squared, my choices are x and x. 7's a prime number. My only choices are 7 and 1. Signs are the same, both positive. And so I've got that common factor. So my final answer is going to be 5 over x plus 7. But remember, when I'm looking for what to exclude, I'm going back to that original denominator. And so I'm worried about what makes that x plus 7 equal to 0 and what makes that x plus 1 equal to 0, both those factors. So I'm going to exclude -7 and -1. That all right?
Yeah, it's okay.
Okay, I'm going to clear that one then. And let's see what the question before is. Oops. Oh, this is fun. Multiply and divide as needed. So does everybody remember, in order to divide, we have to take the reciprocal of this one and make this bigger. So that's going to become the first fraction, x squared plus x minus 20 over x squared plus x minus 56 times x squared plus 7x plus 12 over x squared minus 2x minus 8. And then we're going to change that, multiply by the x squared plus 10x plus 16 over x plus 3. With me so far? Now
Yep.
what?
So wait, hold on.
To multiply, we have to factor.
Mhm.
So, whoops. I'm just moving it over so I have a little bit more room to write. First numerator factors into x plus 5, x minus 4. Denominator factors into x plus 8, x minus 7. Next one factors into x plus 4, x plus 3. Because 12 is 4 times 3, we give me 7. Next one, oops, the signs are different. X, I think if I go minus 4 plus 2, it'll give me the -8 and the -2 in the middle. Let's see, next one, x squared is x times x. 16, if I take 8 and 2 with the same signs, it'll give me the 10 in the middle. And then x plus 3. Now, let's see. I guess before I start crossing out, I'm going to look at what to exclude. To exclude, I'm worried about what makes those denominators equal to 0. So I exclude -8, 7, 4, -2, -3. And then I want to look at this again, because remember originally, that numerator was a denominator. So I've also got to consider those factors, the x plus 8 and the x plus 2. But I've already got those down here. So I'm going to have to exclude those values. Now, common factors, let's see, the x minus 4, the x plus 8, the x plus 3, the x plus 2. So final answer, I have left x plus 5 times x plus 4 over x plus 7. I'm sorry, that's no good. That's not a plus sign, it's a minus sign, isn't it? And doesn't say anything about whether they want us to multiply that numerator out. So I would be fine if you left it like this. I think it would also be acceptable if you did, because it's a multiplication problem, multiply that numerator out to get x squared plus 9x plus 20 over x minus 7. I believe that either one of those are acceptable. And with this, a problem like this, even if my labs didn't accept both of them, I would. Okay. Is everybody all right with the litany of values that we are excluding? -8, 7, 4, -2, and -3.
Yeah, I understand that.
Okay. Beautiful. Then I'm going to clear this one. And yikes, go on to the next. Back to the difference of two squares. How's everybody with this one? When I factor y to the 4th minus 81. How will that factor?
That'd be y to the 2nd minus 9.
Y to the 2nd plus 9. Am I done?
Now you can factor the y to the 2nd minus 9 again.
2 y minus 3, y plus 3. But the one with the plus sign, you can't factor further. After the polynomial, is everybody comfortable with factoring?
Yeah, I got a question about the y to the 4th minus 81. Does the order matter or no? Could you do y squared plus 9 or y squared, or yeah, y squared minus 9? Does the order matter, or does subtraction have to come first?
I'm gonna put you on the spot. Can you remember the name of the property that tells me if I'm multiplying? The order does not matter.
Is commutative property?
So the commutative property of multiplication says it doesn't matter as long as it's on multiplication.
Okay, just making sure.
All right. Factoring this one, let's see, 33. Oh dear, what goes into 33?
3 and 11.
3 and 11. And will 3 and 11 give me that 14 in the middle?
Yes.
Yes, bingo, we got it. Is everybody all right foiling, or do we want to go over a multiplication again?
I'm okay with foiling.
Foiling again. Subtraction, all right?
Could we go over it?
Sure.
Thank you.
With subtraction, I think the key thing to remember is you want to put a little 1 in front and distribute the -1.
Mhm.
We're going to change that into adding the opposite. So the 1 in front stays the same. And then I have to take -1 times each of those. -1 times 3x squared is -3x squared. Negative times negative would make that positive. I'm sorry, that was a cube. Positive 7x squared. Negative times negative makes that a positive 7x. Negative times positive makes that a -4. Now we're going to match up like terms. 8x cubed minus 3x cubed is 5x cubed. Minus 3x squared plus 7x squared is positive 4x squared. Positive 6x plus 7x is positive 13x. And then -7 minus 4 is -11. Again, just make sure that you distribute that -1, which has the net effect of changing every sign on that polynomial that's in parentheses behind the subtraction. Then in order to subtract, we want to change it into adding the opposite.
Mhm.
Rationalizing the denominator.
Um, yeah,
Again,
can we go over this one?
sure. Again, we need the conjugate of that denominator. We're going to keep the same things, 3 radical 17. Instead of a plus, we're going to put a minus. In order to multiply the numerator, we distribute 33 minus 11 radical 17. Denominator, it's the first one squared. 3 times 3, that would be 9, minus the second one squared. Radical 17 times radical 17 is just 17. So that leaves me with 33 minus 11 radical 17 over negative. And a smiley face. And next one. Use the product rule to simplify. We've got the square root of 128x squared. Hopefully everybody recognizes 128 as 64 times 2. So we're going to take the square root of 64, the square root of 2, the square root of x squared to get 8x radical 2. That one okay?
Yeah, can I just get a moment?
Sure.
Thank you. All right, thank you. I'm okay.
Changing scientific notation into a decimal is a +5, so we move it that decimal point 5 places in the direction 1, 2, 3, 4, 5. It increases the magnitude of the number, gives me 8, 7, 1. Those empty spots need zeros, and it
Yeah.
stays negative
Yeah.
1. That one okay?
Yeah, it's okay.
Simplify using rules for exponents. 44 divided by 11 is 4. Z to the 4th divided by Z to the 11th. The variable stays the same. I subtract the exponents. And then I have to remember that when I have a negative exponent left, it means I'm going to put it into fractional notation. And that back to the negative exponent, the exponent is positive when I move that backward to the denominator. That one okay?
Mhm.
Here we would just subtract the exponents to divide. Y to the 8 minus 2 is 6. And we're done. That one was too easy. Simplifying, first we need to distribute. So distributing here would give me 15x plus 5 times 4 is 20 minus 16, combining final 15x 4. That one all right?
Mm. Yeah, that one's good.
What's going on here? It's addition, and I'm changing order. So I believe that's the commutative property of addition. Next one. I think we already looked at using the substituting the 41 in for the F. Is everybody okay with this one?
Yep.
Yeah, I'm comfortable with that.
And then next one is just substituting to evaluate. Is everybody all right with that?
Yeah, it's okay. I'm okay with that.
What wasn't in this one that I know you're going to see on the test, so I can't believe I'm doing this, is a complex fraction. So I'm going to go, close your eyes for a minute, and look at a version of the test and just scooch to the I think that's the only thing that showed up on that first one that we did together that didn't show up on the second. And so let's scooch to that last question, which will most likely be that complex fraction. And oops, I didn't mean to highlight that. What do you think we ought to do with this one first?
Hmm.
Find the least common denominator. So you'd have to factor x squared minus 36.
And how does that factor?
X plus 6 and then x minus 6.
So what would the common denominator be?
So you'd use x plus 6, x minus 6, because you have x plus 6 twice.
And now we're going to multiply both numerator and denominator by that. We're going to distribute it over these two terms. So we're going to have that fraction x over x plus 6 times x plus 6 x minus 6 plus 1 times x plus 6 x minus 6 In the denominator, we're going to have 27 over x plus 6, x minus 6, times the x plus 6, x minus 6, plus the 1 times that. And I think rewriting all of that is a pain in the ass. But conceptually, is everybody okay? I'm just taking each term within the fraction and multiplying by the common denominator. And then I'm going to keep my fingers and toes crossed, because if I chose the right common denominator, let's look at the numerator. When I do that multiplication, the denominator should cancel.
Mhm.
And so that leaves me with like x minus 6. That would be x squared minus 6x plus x squared minus 36. And in the denominator, the whole thing cancels. And so that leaves me with 27 plus x squared minus 36. And then we'll combine like terms and simplify. I've run out of space. What is that? That's 2x squared minus 6x
What?
minus 36 over x squared minus 9. I think that numerator is a couple of steps to factor it. There's a common factor of 2. And again, I apologize because I've run out of space. That would be 2 times x squared minus 3x minus 18, which would be x plus 3, x minus 6. This is x plus 3, x minus 6. The x plus 3's cancel. No, that's x plus 3, x minus 3, I apologize. And so I'm left with 2x minus 12 over x minus 3. Is it any better about these?
Kind of. A lot of work.
Yeah. Yeah, we have a lot of time for the test. Let me just real quick double check. I'm going to clear this, get out of here. I'm gonna go test, whoops. Test, I'm gonna look at settings for class. And you've got 75 minutes, so you've got an hour and a quarter. Go through, do the test first, wait until you've got everything done in my labs, then make sure you do meticulous work, number your work. If you put your work in order, I'd love you more. And if you make sure your pictures are clear, after you finish the test, take the time to upload the pictures into Blackboard. But please realize that when I look in the grade book, I can see when you finish the test, and I can see when you Blackboard when you upload the pictures. I don't want hours to pass in between. I don't want you to go through and recreate after the test. I want to see the work that you did during the test. Okay. So anything else we can do for you?
You didn't erase that last problem, did you? The answer to the last problem? Because I just wasn't quite done following you.
Oh dear. I think it is gone. But,
Okay, no worries.
It'll be in the YouTube video. You can just scooch to the end of the YouTube video and just look at it without watching the whole movie.
Okay, good call. I'll do that.
Okay, because I have done that I hate to admit it, but periodically during the course of a class, if people twist my arm, I might change a due date. And I'm like, oh my God, what did I change that due date to? I don't remember writing it down. And so I've gone back and looked at the videos and scrolled to the end to see, things like that. It's you don't have to sit through the whole thing unless you want to. If I were you guys, I wouldn't want to listen to my voice. Does anybody else hate hearing their own voice on a recording? So,
Yes, I definitely do.
yeah. All right, is there anything else I can do for you folks?
No, thank you for taking the extra time.
Oh, yeah, no, it's your time. This is what I get paid for. Thank you guys for all being concerned enough to be here. I have to say that for Zoom classes during COVID pandemic, I have been happily surprised at how well attendance is and how many people are coming to class. And I don't think I do enough to say thank you to you folks. Do you find it worth your effort to come to class? I mean, it's not the same as being in the classroom, but I try to do the same thing that I would do in the classroom. Is this value to you? Is there anything you guys wish I did differently? Or is this okay?